Right, so here I compare Python to nodejs for something called an interesting problem called the collatz conjecture, or it's also known as the 3n+1 problem. And I did a video on it actually on Python a couple of weeks ago, where basically the conjecture is, well, it's actually written here. The conjecture is the simplest. It's basically, if you have, here it is over here. If you have a number, if the number is odd, then you multiply it by 3 and add on 1. So you do 3n+1. And if the number is even, you divide it by 2. And it produces something, or at least the conjecture is that you always end up in this loop, this 4-to-1 loop. And so I went through this whole decently large video. There's much better videos on the collatz conjecture, but I did it in Python just because that's what I've been coding in. And I thought I'll do the same thing in Node and kind of like compare it. And the reason why is because the previous video I did a comparison, a bit like a benchmarking comparison of Python versus Node, and Node won by about a factor of 10. It was literally 10 times faster. In fact, the person that produced the benchmark compared it with two other languages as well. It's Java and C, and I think it was C or C++, and they were also roughly 10 times faster. So Python is just a slower language. And I thought, you know what, I've got the collatz conjecture, I've run it, and I actually do compute. One of the things that I was doing was I compute the amount of time that it takes. So we can see here that, I mean, all that the collatz conjecture is, and it's quite simple. So again, we got if n is even, divided by 2, and if n is odd, multiply it by 3 and add on 1. So this is the same procedure is actually happening, and we can see here the two if statements in Python, and we can see here the if statements or the if and the else statement in Node.js or JavaScript. And in Python, we've got this while loop here, which actually wraps around this these two if statements here. Whereas in JavaScript, and I literally pulled this on JavaScript out of ChatGPT. So it's not necessarily the fastest function, but it's, you know, and we're not trying to make it the fastest function. We're trying to make them comparable so we can do a good benchmark. So they're kind of like relative. They'll be the same order of magnitude of computations, roughly speaking, to each other. And then at the bottom, it gave us these three little things to logging to the console or printing our statements out, but they're not really of any consequence because we're really actually going to look for loops of a million. So I'll leave these ones in. 3 extra pieces on the million won't make a difference one way or another. And then there's a little time calculation here in JavaScript, which is console.time and then console.timeEnd. So that kind of, and this is the bulk. This is what we're effectively measuring for, which is this time and time end. And we do the same thing in Python somewhere down at the bottom, where we've got a T0 before we start our loops and then a T1 after we start our loops. And we can see that the million, if I hit double control, we see the million up in here. And also if I hit double control here, we see the million loops over there. So we're doing the same order of magnitude or the same number of calculations. I do get slightly different results. I'm not sure exactly why. I'd have to look into the nuances of, like maybe I started the iteration from 1 below and 1 above. But again, for the purpose of computation, that's not going to make any big difference. It's not going to make an ON of difference. So I'm going to hit run, but Python does the Python code's a bit more complete because it does some stuff afterwards. But in terms of the counting procedure, that's all done, or at least the timing of the procedure, that's all the crunching of the numbers is all done here between lines 107 and 115. And in Node.js, all of the crunching of the data pretty much is done over here in this function, the run collatz loop, which is between lines 50 and 60 basically. So although this one's got extra stuff, we can ignore it, like the code crunching has been done before. Now I just hit F5 to run the Python script, and I will hit F5 to run the Node script, and we can see both have been started, and the Node scripts looks like it's already got to the end. and it's computed its results, and it's done it in 2.64 seconds. And Python's kind of like chugging along, and we see that Python does. It will produce a chart afterwards, but we can already see that Python's taken 16 seconds, so it's a good 8 times faster. Let's see what. I was expecting to get another pop-up somewhere. Yeah, I did. We do get these other pop-ups in Python, so that's the collatz conjecture pop-up. But basically, that's pretty much it. So the JavaScript code again is running, 8 times faster. If I run them on their own, and I'm not sure if it goes a bit quicker because I did have like a 1.6 second run. Here we go. Yeah, sub 2 seconds, 1.9 seconds. And I'll run this one separately, so they're not even running at the same time, so there's nothing in the processor. But basically we've got 2 seconds versus about 10 to 20 seconds, so quite a big difference for pretty much the same procedure. The only difference between this benchmark and the last benchmark, once again we see 12.8 seconds versus 2, so six times longer. There's our little beautiful chart in Python that we show with the matplotlib. And I'm no expert in JavaScript. Yeah, I'm just getting back into it, and it's more like I just sort of do some benchmarking into some tests, because Python 3.11 is supposed to be faster, and or 25% faster than its predecessor 3.10. So it's still disappointing relative to other languages in terms of speed. I guess the final piece is that both of these procedures are actually going into a dictionary, or in JavaScript a dictionary is called an object, and in Python a dictionary is a dictionary. They're both hash tables effectively, and I thought maybe I'd be more forgiving to Python in the sense that a list in Python is not the most efficient thing. So maybe if there were lists or something involved in the previous video, here we're not even looking at lists, we're looking at hash tables for both. So it's the fastest like storage or data access for both. Here are collatz in nodejs. On the right hand side, it's going into, where are we there? We do create an empty dictionary somewhere and trying to find it, and we're populating that. So there we go, our dictionary in line number 54. So we've got our dictionary there, and also the same Pythonic version of it. We create our empty dictionary here on line number 108. So we've got an object there. These two are equivalent. If I just do the line of it. Let's have a little ponder if I can get the line of it up. But basically we have this dictionary here. If I can get a pencil mark going. This dictionary here. Oh, not being able to draw with the pencils. Try that again. No, I can't draw with the pencils. But the dictionary here on line 108 and the dictionary here on line 54. Basically, they are the same thing. They're the hash tables. So we're on a like-for-like basis, and Node is, I don't know, 5 to 10 times faster than Python.